Good morning, good afternoon, or good evening, depending on where you're joining us, and welcome to day 3 of the virtual festival, AstroFest, South Africa's first digital festival, astronomy festival, or as we more commonly like to call it here, AstroFest, the lockdown edition. This program is jointly presented by the South African Astronomical Observatory, who turned 200 years old on the 20th of October 2020, and SciFest Africa. Now, SciFest are well known for hosting the largest science festival in the country, and they have embarked on an ambitious project hosting a 6-month festival ending in March 2021. Thank you all for joining us. My name is Pran Govender, representing the South African Astronomical Observatory, an entity of the National Research Foundation. Today, being the penultimate day of our 4-day digital festival, I would like to sincerely thank you. Thank you to all of our participants, attendees, to all of our friends joining us from Facebook. Thank you for the amazing interactions, the great comments, and the great feedback. In yesterday's edition of our virtual festival, as we traveled through our universe with you, we journeyed into cosmology and artificial intelligence. We explored the search for life beyond Earth, and to probe even further, we began exploring some international best practices on science engagement using digital platforms. In today's edition, we start off by joining India. We are honored to host Mr. Samir Dhurd and Ms. Sonal Tarva. Samir, the in-charge officer of science engagement at IUCA, the Inter-University Center for Astronomy and Astrophysics in Pune, Maharashtra, India. Now, when it comes to going big, IUCA's SciPop certainly have proven themselves to be in a league of their own, holding the Guinness Book of World Record for having the most number of learners attend an astronomy program at the same time. Congratulations. Learners attended a lecture followed by a hands-on activity, allowing IUCA to be recognized for their dedicated efforts towards the promotion of astronomy. I think what we take back from this is that Samir and his team are most certainly leaders, and we are indeed grateful to have you in today's edition of AstroFest. To our participants and friends from Facebook, should you have any questions, please make use of the Q&A feature here on the Zoom feature in the Zoom session, or on Facebook, please use the comment section. Welcome, Samir, and over to you.
Thank you very much, Pran, and warm hello to everyone in the audience here. In fact, it's a pleasure that I've been able to participate in this great festival which is being organized remotely, because in general, I think it would have been difficult to reach cross borders and have such a great audience here. Of course, Pran has introduced me. I represent IUCA, which is the short form for Inter-University Center for Astronomy and Astrophysics in India. And we are a kind of a partner with the SAO, which is celebrating its 200th bicentenary. Celebrations are happening this year. And we are also a partner in the Southern African Large Telescope. So that is our research interest and interest in astronomy. Of course, all our scientists here are an inspiration to everyone, not just by being scientists, but by being popular scientists. So they have taken up efforts always for over the 30 years that IUCA has existed. We've been doing outreach and informing people about this research, which many of them find very complex to understand. Of course, nowadays there's a lot of popular literature also around in the world, and therefore, it seems that such things are accessible. But then you can never guarantee the quality or the factualness of the content. So IUCA does a lot of programs which kind of guarantee that the correct message and the correct information reaches all levels of people, including especially students and teachers who are kind of the next generation builders. So we therefore indulge in a lot of workshops here in India. I can see 18 participants here, and Pran just mentioned that I gave a lecture to 1,800 students at one time, and we did a lot of hands-on activity. I'm in fact looking at the participants list, and I can see one of my inspirations, Derek Fish, is also here. So hi, Derek. And then, of course, so many of you who are helping organize this and attending this workshop. So the topic today is going to be Learn It Yourself Astronomy. And I'm being helped by my colleague Sonal, who will be seen and will join us later during the workshop. We are going to miss the feeling of actually having a workshop with all of you in live, in person. But anyway, I am going to try to do a justice to it by showing you a few slides and carrying on with mastering astronomy by yourself. So the universe is there, and just make a quick case of why we should be learning about this subject. Which seems to be too far away and from us. The objects seem to be too far away from us. But yeah, I mean, if you actually see, we are all part of the universe, and through astronomy we learn about it. We get a feel of what the universe is composed of, what goes on in the universe, and in fact we also get an idea of how we came into being and what is going to happen to us. Right? Not the astrology way, of course. That's a very different use of similar observations of the sky. But with astronomy, we get a real perspective. And if you get a perspective, like for example, 400 years ago, Galileo made sure that we understand how we are placed in the solar system, that the Earth is a planet which goes around the sun and not the other way, right? That kind of probably led us to understand that we are not very important in this universe. We being very tiny, we have to struggle a bit more to better our chances of survival and existing here in a better way. So that's one of the reasons why I think astronomy should definitely be studied, and not just as a subject in school, but as a way of life, right? So also the other case is that space is happening right now. We all know that various countries are in a space race again. Last century it happened more because of political reasons. But I think now the reasons are clearer, and now we are going to really go into onto other planets and further on. So in this kind of a environment where this will be the current trending thing in the coming decades, we need to be aware of it. If you're not aware, you'll be left behind. So not just us, our children also need to be trained in properly understanding things around them, properly understanding happenings, properly understanding mechanisms, and to base their actions on facts. This has a little societal importance also, as you will notice, but I'm particularly referring to the understanding of the universe and of what is happening in the domain of space. So in that, what we promote is learn it yourself. Learn it yourself is a way in which you don't give up educating yourself when you leave your classroom and finish your school and go home on that day. Education continues, and you keep learning with things all around you, right? And that is what I'm going to try to present to you quickly in this workshop. So a few more points just to stress that astronomy itself can provide us a lot of practical uses. And you'll notice that in the future, energy is going to be a major area of concern, where we will be looking for more ideas and resources. And in fact, even now, one of the most important experiments is a nuclear fusion reactor, which would give us energy for almost for free and without pollution. And that information has come to us from the working of the sun. We will also have to consider safety, because always we think of ourselves in a kind of a safety bubble, but there are objects around the solar system which we may not be aware of, and which are in fact always going past the Earth. And so the world needs to be prepared for such things. We are, of course, very prepared for our immediate neighborhood with others around us, but there are others in the solar neighborhood who might directly affect us in the future. There's also the society. As I said, we are going to improve, we are going to go to space. And in any way, if there is a different future, our understanding and awareness of our role in general, of our role and our place in the universe kind of helps us accept and develop ourselves much better. So that being the case, I think if this is your grandchild, then we need to prepare them for being successful and being leaders. So with that little introduction, let's launch and let's go into the LIY part of this presentation. So I always believe there is a world of things, pun intended, to use and learn from. So we are always at IUCAA, we are always promoting this deep understanding of everything around us. We sometimes, of course, always come across data and facts, something like this in various magazines or books or even textbooks, where you'll be given such numbers which would impress you, like the sun's mass is 333,000 times the Earth's mass, or Jupiter has a very similar rotation period compared to the Earth. Distance between Earth and Moon is around this many kilometers. So these are numbers you enjoy for a while, and then you say, okay, I can't remember that huge number, I'll forget it, right? So, but then if you would actually dwell on the minor print, not on the number, on the minor print, and try to understand what that implies, I think we could learn a little bit more. But that connection doesn't happen because there is no experience related to that. We are not experiencing anything about this information. So me and Sonal in this short presentation workshop would like to present to you a few activities out of the many that we have been doing with students here at IUCAA. A few activities which could quickly give you a glance at how LIY can be very effective. So to start with, look around. Maybe look for what's in your pocket. Can you find a coin in your pocket? If you can, then this coin itself can be a nice tool. And you take your coin and put it to your eyes like this, and actually try to measure the moon, let's say, or any other body which is far off. But to relate to astronomy, I will quickly dwell on this activity in which you can use a coin to measure either the distance or the diameter of the moon. Okay, so what do we have to do? This is a nice picture of the moon. Sure, you've seen a full moon. And the moon also changes its phases. So that's another thing we should notice and maybe be tandem with when we are trying to experience astronomy ourselves. But let's say when the new moon, next full moon is going to be, okay, which will be next week sometime. What you could do is you could take your coin and you could move it slightly away from your eyes slowly, so that you are able to cover the moon fully. Now at the bottom here, you can see if the moon is yellow here, this moon, and this is your coin, you have to move it away and closer, right? And to make it quantitative, to make a good measurement, we are also using a scale or a ruler or something to measure the distance of the coin from your eye. And a very simple exercise. You could even use your hand and later measure it if you want. But what you have to do is to exactly cover the moon. So this is how the moon would be covered, not less covered. So the coin should not be showing a thin ring of the moon, or it should not be completely covering, so that there is more area around the moon which is still not under the coin. So here you see the coin has perfectly covered the moon, and that is a good position to take a quick measurement of where the coin is compared to your eyes. So the distance between your eyes and the coin can actually tell you just a moment. So it can actually tell you something about the geometry that you have learned in class. So you've learned about similar triangles, and you know that in that there are some ratios which in similar triangles are very similar. The ratios are similar. The sides may not be, or the perpendicular may not be, but the ratios are similar. So in this particular case, you can see that the moon here, which is a much bigger body, much farther away, and the coin here are kind of seeming to occupy the same angular size in your eyes. Okay, so if your eye happens to be here, and this is the angle at which if you join the edges of the coin, this edge to your eye and back to this edge, then the angle subtended by this coin is same as that subtended by the moon if the coin is perfectly able to cover the moon, right? So that is what we have done, and therefore we know now that this E, the small e, okay, and the diameter of the coin here, okay, these are known to us because these are things we can easily measure. Now if we see the ratios, then we will know that the d by d and e by e, so this distance to the moon by the distance of the coin from the eye, have a ratio, and these ratios are the same. From using this equation, if we can fill in 3 of these numbers, we can get the 4th. Okay, so in this case, if you know the diameter of the moon, you can find the distance to the moon. If you know the distance to the moon, you can find out the diameter of the moon. Okay, and this is a very nice exercise one can do. And as I said, all you need is a coin and a ruler and maybe something to note down with the numbers. So lovely exercise in which you can put in, let's say, if you know the diameter of the moon, you can find out the distance to the moon. So this is, I'll also suggest a related activity. In fact, if you're using a coin, why not try to use something else that is even closer? You may not always have your coins in your pocket. So what we were measuring there was an angular scale in the sky. So if you notice, the sky is more like a dome on top of our head. So it's like a huge dome. Okay, and if you look directly from the east to the west, then you think about angles, right? Then you can see that there would be 180 degrees angles, 180 degree of angle between the east and the west horizon, exactly east to exactly west. Okay, so if you can imagine that to be like a protractor that I have here. Okay, so I happen to have a protractor here in my hand. Okay, I hope you can see it. So this protractor is 180 degrees, right? And so if you use your hands, I'm trying to do this here. Okay, so if this is 0 degrees, your hands are at 0 degrees between yourself. If you do this, this is 90 degrees, right? It's 90 degrees. If you go here, this is 100 degrees away from this hand. Okay, so you can see you can use your hands also for angle measurement. So this is a very large number of degrees, 90 degrees. But if you want to see smaller degrees, like for example, the size of the moon is quite small in the sky. It's not 90 degrees. It doesn't cover half the sky, correct? So to find such distances or distance between, let's say, some stars or the size of a constellation or something else in the sky, you have to you can have easier measures. For example, if you extend your hand, now this is the important trick to remember, that you have to extend your hand to 1 arm's length. So you have to go 1 arm's length away, and then you put up your pinky out. You can see the distance is exactly 1 arm's length. You are stretching out your hand. You're not holding it closer. If you hold it closer, you can probably cover the whole sky with your finger. But you have to hold it at 1 arm's length. And if you do that, your little finger here, as you can see in the slide also, can actually cover close to 1 degree in the sky. So you can probably have 180 of your pinkies, your little fingers cover the whole sky. You don't have that many, of course, but then if you want to go for bigger measures, here's a scale. So you can use your first 3 fingers, but again at an arm's length. Okay, so at an arm's length, the first 3 fingers, the width of them would be covering about 5 degrees in the sky. Then there's your knuckle, which you could extend again and look in the sky. Anything which is within the width of your knuckle, okay, that is 10 degrees. That area is 10 degrees. You also have 15 degrees with your, probably this is the rock-on sign. And then there's 25 degrees where you're 20 to 25. This might not be so accurate, but okay, 20 to 25 degrees, the distance between your thumb and the tip of your little finger when it's extended out like this far from your body. Okay, that's about 25 degrees. So you can use your own body as a measurer of angles in the sky, and then find distances between stars, distances between objects. There are other objects in the sky like planets, there might be comets. So there are so many things that you can find out in the sky. In fact, if there is also some angle measurement needed on the Earth for a far off thing, you could try this method as well. So what is the activity related to this? I was suggesting that you must have heard of the supermoon, right? And of course, on that day, the moon doesn't wear a cape and go flying. The idea behind the supermoon is that it basically comes closer to the Earth or goes slightly farther from it. Okay, so this is something which is well known to us, and this is because of the elliptical nature of the moon's orbit. Okay, so it is sometimes closer to the, I'll have a picture very soon in another slide coming up. So when it's closer to the Earth, it looks slightly bigger. When it's slightly farther from the Earth, it looks slightly smaller. So this change in diameter can be approximately change in apparent diameter. The moon itself is not shrinking and expanding. So this change can be up to 14%. 14% is quite a large number. And if you can see the bottom of the slide here, the nearest point and the farthest point are approximately 40,000 kilometers apart. Okay, so that's a big amount. So that is something I'm asking you to try to measure. So you will know of supermoons because there will be newspapers, etc., announcing supermoons. But there's also little moons or mini moons. I think that's what they call it in the trending language. So mini moons are also sometimes announced. So if you can find the diameter of the moon is same, but if you can find the distance to the mini moon, distance to the moon on a mini moon full moon, and the distance to the moon on a super moon full moon, you can make your own experiment. You see, you've just used only a coin, a ruler, and the knowledge that the diameter of the moon is this much to find out this distance change. And you can yourself verify whether all these things that the newspapers are saying about it are true or not, right? I'm not saying they're false. I'm saying you can get into a habit of actually verifying things. And you don't really need to be a rocket scientist and really need a rocket to measure these things. Of course, you will also probably be able to understand that the accuracy level that you achieve with this kind of instrument that you made might not be so good. So probably your student could be inspired to make a more accurate measurement device. You see, this is the start of an engineering mind. So we have done a simple activity with very simple tools, but and the results are also there, exciting results. But it's not just that; it's also inspiring them to think about accuracy, think about the individual thought about making up unique devices which could be more accurate. Okay, and actually finding a solution to a problem which is a real life problem. They have experienced it and they want to find a solution to it. Okay. The moon, of course, is one of my favorite objects in the sky, and one of the best things to start with when you're just beginning astronomy. So you can also keep a track of the phases of the moon. Like I have here suggested that people could draw the moon. They could keep looking at the moon once in a while. They could take notes of how the phases change. And there are actually activities suggested in textbooks where a teacher can use a small a ball here and a torch, which I don't have right now, I'm sorry. So you can use the light in your mobile phone maybe to create these phases. So you can move around the moon and see it from different angles. While if this was the light here, it would shine on this face and you could move around, or you could move the moon around you and see the phases changing, right? So all it needs for this activity is a bulb and a ball, which can then show you the phases. Very similar to the moon. And of course, if you extend that into the field, then the children could actually go and observe these changes. They could see that these changes happen over a certain period of time, and they are cyclic. Also, the moon's position changes every evening. The time of rising changes every evening, and they could deeply go into thinking about the moon and its orbit. Okay, if they do, then I would suggest that they also think of, what is the effect of the moon's orbit, okay, and why does the moon orbit the Earth? And of course, they could also go into the nitty-gritties of the moon's orbit being elliptical, and because of that, the supermoon and the mini moon is being caused. Okay, so yeah, I mean, I love to show this picture usually of the Earth and the moon on a seesaw. This is something children enjoy playing on themselves, and seeing this, they can understand that if the moon and the Earth were to play seesaw, the Earth would have to sit very close to the fulcrum, and the moon would have to be at a very, very far off end. Okay, and this is kind of leading them to understand the center of mass. This is actually a kind of picture of the moon's orbit, where you can see that the center of mass of the Earth and the moon system actually lies closer to one side of the Earth. Okay, because the Earth itself is moving, so the center of mass is not a fixed point in the Earth somewhere, but it's a fixed point in space, and both the Earth and the moon orbit this one. Okay, now this, of course, if you want to understand this, we could have a simple demonstration with, again, using simple things. Your body, finger is the fulcrum, and you try to balance this kind of a ruler on your finger, right? And then you try to put some weight on one side, and you see that you have to move your finger onto this side towards the weight to find out the balancing point, which is the center of mass of the system. Now you can extend this now from the observations that you take from this. You can make it more accurate by not using your finger, but using a more sharper object, or thinner object. And you could then use standard weights and go on to more quantitative and actual measurements of really known weights. So those things are easily done. But only thing is, you have to start with something very simple, which the children would like to start with. If they're right away put into a lab kind of environment, they will not feel so connected or interested in it. In fact, there's another thing that I suggest sometimes, and we do this in classrooms, is that we get children to actually hold each other's hands and go around each other. Right? So this is a popular game in our country called Fugdi in our state here, where there's a lot of music played, and they do this very fast. I'm sure you must have seen or tried this out also. So again, there's a center of mass here, and there's an axis also around which they're going around each other. And these two are of equal mass. But if one of them was probably a small baby, and this would be a mother, and they would go around, it would be more like the Moon-Earth system. So you see, you can make connections with between the things that you're trying to learn and the things that are there around you. Okay, I have to also show you something else through which you can learn astronomy yourself. So I'll quickly show you that the picture which I was imagining, in which the sky is like a dome on top of your head. See, so this is the dome, and there are several things like the cardinal directions: north, east, south, and west. And then there's something we call the horizon, which is the place where the Earth touches the sky, seems to touch the sky. It's not a real thing, but that's something we can use as a coordinate system, right? There's also something called the meridian, which joins the north to the south pole of the sky. And then the point on top of your head is called zenith. So these are things which you could yourself know, and then you can go on to explore the other things in between these. So the whole sky is there. At night it looks very different. It's not blue, it becomes dark with stars studded onto it. So for this, although since I have very little time, I'll suggest a software called Stellarium. It's a free software, and you can easily install it on your computers. I'm just guessing that all the people here have computers to install this and play with it. Or you could also find some applications on your phone. Stellarium is also a phone application, which you could install on your Android phone and play around and learn more about the sky. So I'll quickly give a demo of the software Stellarium. I'll just stop sharing this and give me a moment, please. Okay. Great. So here you can see Stellarium, the software, which is really one of my favorite softwares here. And I can All right, so you can see that this is for the location of the sky is we are looking towards the south, and the moon is in the sky. Yes, that's surprising. And you can see how smooth it is. You can actually click on it. I'm clicking my mouse on it and actually moving the sky around, so you can have a lovely look at everywhere. So let's say we fix on east, and at the bottom you can also see that this here it says Earth Pune. That's where we are, but we can always change the location to go to Cape Town. So assuming all of you are in South Africa and somewhere close to Cape Town, and you see suddenly the sky has slightly changed. The moon, which was higher up, is lower down here. Okay, and that is because again it's afternoon. It's about 3 p.m. for me, and it's only about 11:30 for you. So therefore, the moon has yet to rise up high, and it's the same moon. We are looking at the same moon, but we are slightly off phase. Okay, in this there is also an option to change your time, so I can do that here, and I get the date and time window. So the date is shown here. I'll not change the date, but see the magic. I can change the time, and you can see that the moon is rising up as the time goes past, and at the time which is here now, close to the time which is here now, it's gone really high, right? And that is something you can yourself experience. So that's one thing. Then you can, of course, I wish I could have been there and showing you the sky in the evening. So you can see at close to 5:30, I can now move slightly to the west, and we go past north and we come to the west. And what's happening in the west? As expected, at this time we are seeing the sunset, and with the sunset after 6:30 or so, you see the stars. Yes, you see the stars start to come out. And where's the moon? The moon is high up in the sky, and there is something joining the moon. If you zoom out a bit, you can see the labels are given. The moon is being joined in the sky by Jupiter and Saturn, and you can in fact even zoom in there, and the software of course shows you slightly more wide angle than your eyes would see. So your eyes would see a really lovely sight with a crescent moon and Jupiter and Saturn, which would look like two bright objects just close to the moon in these positions. So you see, you can plan your observation of the sky right away with Stellarium, and you can go out and then take a note of what is around the sky. Okay, so say after you find moon and Jupiter and Saturn in a very nice triangle, in fact, today for your location, you can then look for other things around you. Okay, so we come back around to the Earth, kind of, and in the western side there's a bright star called Antares. Okay, you may not probably realize the importance of it or what constellation it is associated with. So for that, Stellarium basically allows you to turn on the labels of constellations. So I can turn on these names, and you see how easy it is to see and identify the constellations. I can even turn on the diagrams, which basically tell you how the constellation is imagined as a line diagram in the sky. So that Scorpius basically happens to be a scorpion. Okay, it's an imaginary scorpion in the sky. This is one of the first, I suppose this is one of the first constellations that kids learn to identify in Africa, in South Africa, I would suggest. You can go around in the sky, you can look around, there will be several other constellations. There is something called Cygnus, which is a swan in the sky. There's a horse called Pegasus, there's Pisces, and as we reach east, you'd see many other constellations, but then there's also the bright red Mars, which is coming up. Okay, again, as I said, I would have loved to be there and show you this, because Mars right now is at one of its closest positions to the Earth. So going around the sun, both of them have come to a place where they are actually very, they are at one of the least distances from each other. Sometimes if they're on the opposite side of the sun, if you imagine my head to be the sun, and if this is the Earth, this is Mars, then they're on opposite side. But right now they have come to the same side. They're of course not on top of each other like my hands, but they are at the least distance they could be at. So there's Mars for you. And if you have a telescope or so, you could always train it to it. and have a look. Jupiter would really look beautiful with its 4 big moons, and Saturn has its ring. And if you have a small telescope, which you could actually make using very simple things. So at Ayuka, you can see I have this telescope in my hand here, and it's made out of plastic pipes. So in fact, and I can always just take it out. I can just dismantle it very easily. And you can see I can take out the lens, I can change the lens here, you can look through the lens and show it to you. You can find out its focal length if you want, and just reattach it back. This is the eyepiece here, which again is a very cheap plastic eyepiece, but good achromatic quality. And the rest of the thing, as you would note, maybe if I show it a bit closer to you. So this is all made out of plumbing things. This is made out of, this is a wooden block which we roll our rotis on. And these are plumbing things, pipes, PVC elbows, connectors, etc. All these things are used. Even this is a PVC pipe. Here I've used a transparent one just for demonstration, but we use of course, obviously we use a darker one here, another 6-inch irrigation pipe. So this is very simple to make. You just need some lenses and you can make the rest of it. The cost which which would make you think twice is just taken care of by the from plumbing instruments. Okay, so you could do that, and if you had such a thing, you could train it on to Jupiter, and our Stellarium software allows all that, and you could just zoom in, as you can see, and you can check whether the moons of Jupiter are visible and what position they are in today. So this is the position, this is Jupiter in the center, and the moons are around it. Of course, if you have a bigger telescope, this is not big enough. If you have a bigger telescope, then you could in fact see all these actually slowly moving over many hours. I'm sure SAO has a lot of activities in which they have telescopes put outside, and they show the people coming to the center. This would also be applicable, I'm sure, to the science center and the planetarium. But this is a virtual planetarium. This would be at your home, and you could always enjoy. You could learn about the sky. And finally, just to give the ooh factor, yes, here we can even turn on the artwork. So you now know that Antares is a star, is a bright red star in the constellation Scorpius, which is a scorpion. But now you can imagine it much better. So lupus is a wolf, but the stick diagram probably didn't explain it better. Now it does. And so go ahead, use this software, turn it around, turn it to daytime, nighttime, to any place in the world, and have fun looking at what are the objects in the sky. So that is something you can do with the stars. Of course, other than that, you can always take more notes, go further yourself. You can find out distances between stars, see how much they vary in their brightness. You can find out, you can make your list of the brightest stars that you can see. Go find out what these stars are. There are sky maps available freely. Of course, if you can always use Stellarium, but there are sky maps which are available freely on the internet as well. Several good sites like skymaps.com, for example, so simple to find, would give you maps of the sky. And they would also give you customized maps for northern hemisphere, southern hemisphere, or for your own location. Right. So go ahead and make use of these, and you can always learn these things yourself. So I have also I have to point out to you that for really good skies, then these are the months like November, December are the good months to observe meteor showers. Okay, so meteors are flashes which come in the sky, and sometimes people say you can wish on them. But in a meteor shower, you can have up to 20 to 100 of these going past every hour, and then you'll run out of wishes if you actually just even attend one meteor shower observation. So these are some things you can watch. And nowadays, of course, there's also man-made satellites which shoot across the sky, but at a much higher altitude, at a much higher height, about 200 kilometers above the Earth. Elon Musk is putting out a lot of objects out there within his constellation of satellites. So you could probably also see some of them going up in the sky. So these are things you can yourself experience and have a look by yourself while learning astronomy. So I think now I'll stop and I will pass on the flag to Sonal, who will actually tell about how she shares some activities, some concepts in a textbook with teachers, where they themselves can play games with their students and explain to them a few concepts. So Sonal, would you come on video? Yes, there she is. Say hello.
Yes. Hello,
I'm going
everyone.
to go on to mute. Sorry. So I'm going to go on to mute, and Sonal, please take over.
Thank you, Samir. So, hello, everyone. And as Samir said, I'm going to share a few ideas where we can use ourselves as a tool to learn astronomy. So, whenever you are teaching your students or teaching your kids about some basic astronomical concepts like day and night or a year, how can we use ourselves as a tool? So we have made a small video clip here. So let us look at the video clip, and while looking at the video clip, we will pause at some positions to understand what the activity is actually showing us or telling us. Okay, so we'll play a video clip here. Yes, so here is a video clip. It's a short one, which is going to explain us how we are using ourselves as an astronomical tool. So here I am holding a globe in my hand, but it's of course not necessary at all that you should have a globe with you. So you are yourself now going to represent the globe or earth and how the earth rotates. So if the axis is extending from your body, so from your feet through your body to the head, then how the earth rotates. Okay, and this is how, if we can pause the video. So this is how we can explain how the earth rotates. So let me show you what we explain over here. So here is a globe I have. Okay, without having a globe also, if I consider myself as earth, my head as earth, and nose of me is representing the place wherever we are. Suppose I am in Pune right now, you are in Cape Town, or some of you are in America. So what we can tell the students or our kids is the nose represents the place where we are. So if the sunlight is coming from this direction, where the camera was or camera is, let us consider that direction as the sun. So when I am facing the camera or the earth is facing the sun, all we know or we can show that, sorry, I don't have a bigger flat surface over here. What we see, the sky is a perpendicular plane. Okay, a plane that is perpendicular to this point. Okay, so this is the flat plane of sky which we can see. So the sky dome above this plane is visible from the place where you are. So now suppose I am in India here. Okay, as I am in India, the plane I can see is something like this. But at the same time, if my friends are in Africa, they are going to see a different plane. Okay, so we are going to share some common objects like the sun right now, but there will be some different objects. So using this, we can teach or we can learn about what how the sky or objects in the sky move. These can also tell us how the sun rises from east to west, while I am turning anti-clockwise. The sun or the camera in front of my nose is going clockwise around me. Okay, so this can teach us the direction of rising and setting of stars, and this can give us perspective that how actually the rotation of the earth or spinning around its axis is a reason behind day and night or rising and setting of the stars and the sun. So this is one activity where we can use ourselves to teach day and night. Now let us see what else we can learn. So the another aspect which is common, which we use is year, a year. When so I'm calling my friend here. So Samir is here. He is of course the sun, and now we also teach students that Earth revolves around sun. So what is mean by revolution? Here I'm going to show only revolution and not rotation, because what we know is Earth is not only rotating around itself around the axis which is straight, right? Passing through feet to directly through head, but it is tilted like this. So to show that angle, what I have done is it will be difficult to rotate for us like this in a tilted way. You all can imagine how that will be. So what we do is we have just extended our arms. Okay, so I have extended my arms to show or represent the tilted axis of the earth. So now what revolution is? When spinning is showing us that the sky changing in front of my nose, revolution or spinning around other object or the sun, it's showing me something different. Please give a closer look at the axis. The direction of the axis is not changing. And this can be used to understand how for northern hemispherians we always give an example of pole star. Why doesn't a pole star rise or set, but all other stars can be seen rising and setting around it? So in southern hemisphere, I'm sure we can give examples of a few constellations which are nearer to the south pole, and then we can show how those are circumpolar and have a shorter circles in the sky, make shorter circles in the sky, but never rise and set. Okay, so we can use this to show how the axis is constantly pointing towards only one direction throughout the year. That is how the pole star doesn't change its place, or all other bodies can be seen going around the axis of the earth. Okay, now as the earth is moving, it is reaching at certain points, right? We know that a year is of 365 days, almost 365 days, right? So in these 365 days, the earth is changing its position around the sun, in its orbit around the sun, and using the axis, what we can teach is, let us pause the video here. Yes, maybe the next step we can pause. Yeah, okay. Yes, so let us pause video at say equinox. Yes, so here what we can see is the axis is tilted, right? The axis is already tilted, it hasn't moved at all, and it doesn't change throughout the year, but the earth, or half portion of the earth, or half of the sphere, the earth sphere, is facing the sun, while the other half is behind, and the earth is going to rotate like that when half of the earth is getting sunlight and half of the earth is not getting it. So this point we call as equal day and night. So when the earth reaches at that point of the orbit, it is equinox. Okay. Then when the earth moves forward in its
Also,
orbit,
also at this point, both the poles are receiving the light. That's
yes, right. So both the poles are also receiving the light. And now as the Earth moves forward in its orbit, let us see what is happening. If you observe, now the southern hemisphere, okay, the left hand of mine, you can say, is getting closer to the sun or tilted towards the sun, right? So Earth is not getting too close or too far, but the tilt can show us how the southern hemisphere is tilted towards the sun more, while northern is tilted away from the sun. At this point, the North Pole is not going to get the sunlight, while the South Pole is going to face a day. So this is how we can also teach how poles have 6 months of days and nights alternate in a year. Okay, so when North Pole is having a day for 6 months, the South Pole will be facing the night, and exactly opposite will happen. At the same time, when Southern Hemisphere is towards the sun, it is getting sunlight directly or a direct sunlight. So it it uh, uh, it experiences summer. Okay, while the northern hemisphere is getting tilted sunlight or tilted sun rays. And what do we mean by tilted? Is the same sunlight, same amount of sunlight is spread over more area, and that is why it forms an elliptical patch, which makes it colder for us. So when you are having summer in South Africa, we are having summers in northern hemisphere. Okay, so this is how we can explain how seasons occur due to revolution of the earth. Let us see how it occurs. So as the earth moves forward, you can again see another equinox when you can see the sun is again the sun, both the poles are getting lit, sunlit. Half of the earth is getting light and half of the earth is in facing night. So this is another equinox. Then as the earth moves forward again, we come at a point where the northern hemisphere is now tilted towards the sun. Okay, so we or northern hemisphere people will experience summer, while southern hemisphere people will experience winter. So let us play this video and see what fun we can have while teaching this when kids themselves are performing as they are sun or earth. They are acting as sun and earth. So now I'll take a globe in my hand. It is not needed, of course. You can see that I had exaggerated the axis a bit, but Earth's axis is tilted by 23.5 degrees. Now when the Earth is at equinox point, you can see uh, uh, I just explained that half of the globe is lit and half is not. So equal day and night. While doing this rotation, you can always emphasize on the point that the axis is not changing. It is always pointing in the same direction. Even though throughout the year, the sun is shooting its rays more severely on one of the hemispheres, right? Like this one. Now you will see that the southern hemisphere is having summer. Okay. So this is how we can teach our kids or students easily how days and how seasons occur. So how the revolution of the earth around sun and its tilt. So basically the tilt of the axis is responsible for seasons. So this is how we can use ourselves as a tool to learn and to teach astronomy to our students, kids, and fellows also. So along with that, I have a short presentation, which if we have time, we can show a few slides. So along with these, there are other things which we can teach using these activities. These activities are called as role play activities. where we ourselves are playing a role of some astronomical body. Like I was being Earth, Samir was being Sun. So similarly,
Do I
we
need
can
to
play.
show that? Do I need to show the slides, or are you doing it?
No, I can tell if I think we are out of time. So I can
Okay.
just tell, yes, I can just give an idea. We can also teach students about how times are changing. Like when the earth is rotating like this in anti-clockwise sense, you can actually see the sunlight coming from my window here. So how sunlight is moving in the opposite direction, you can actually see it. Okay. So here you can see that when India is here, when sun is over India, and it can just be seen rising from this part, which is 6 hours away from India. And then it comes overhead at Africa, and then the Earth rotates like this. So using this, what we can tell is we can teach how time is different in different countries. So using role plays, we can also teach students how phases of the moon occur, how eclipses occur. And apart from that, or apart from astronomy, there are a few examples which I had thought of, which can be used uh, in this way to teach in this way. Like when we teach sets and subsets in mathematics, can we try doing or splitting the class in two different what we can say, in different sets, sorry, different subsets. Most of the times a single class has students who are born in the same year, but their birthdays might span across different months, so we can make subsets of their birth months. Similarly, while teaching chemistry, what we can do is we can uh, try out giving out students different cards of their elements and the electronic configuration. So valence electrons, what are the electrons in their last shell, they can define, they can split themselves into those subsets, and they can then teach themselves or learn that how valence electrons are responsible for the bondings or ionic or covalent bond, how electronic configuration is. So we can try these ideas using role plays. So I think our time is over, so I'll stop here and pass on to Samir. Thank you.
So thanks, Sonal, and that was about role play and playing games with your friends, with your family, with anybody you can find who has interest to learn something concept. So I'm sure children are creative enough to create their own games if given a concept. So we are the oldies who have tried to come up with some games, but I'm sure if you allow children to just brainstorm, they will come up with more excellent games to play. So all these things can be done for learn it yourself kind of activities, which would be additional to what they learn in school. So it was a pleasure to share all these things in a very short time. In fact, like the things which Sonal was presenting takes about 2 hours workshop to go through, and what I was presenting also, there are lots of things which have been, you know, cramped into one small 20-minute slot. So thank you for being patient and listening to this hurried presentation in a way. We are expecting questions, but even if you are not able to ask them here or are shy to ask, please feel free to mail us at this email ID later. Pran, please come on and take over the proceedings. Thanks.
Thank you so much, Samir, and thank you, Sonal. So this was actually a really fantastic way of looking at the unique methods that we can use to convey astronomy. You touched on chemistry, you went into physics, you went into a little bit of earth science that can be implemented into classrooms. Samir and Sonal, I think one of the best things about your presentation, and I'm sure India and South Africa and countries where we may not have all of the resources that we need in a classroom in order to do these activities. Firstly. Secondly, even in classrooms where everything is present, one of the most important things is that if we engage with learners and get them to do these themselves, they tend to be more hands-on and they tend to learn more because learning should be a fun experience. And rather than performing these demonstrations, just showing them how to use role playing as a means to understand science is a fantastic way to get them to understand these concepts. So we do have a few questions that came up. The first one from Sharid Khan. The use of degrees was fantastic. I will definitely teach it to my learners. Where can I find these to print out?
You mean the finger indications? These
Yes.
are, I mean, again, these are freely available on Google. Just find out, search for using fingers for finding angles.
Okay. Your web page as well. I'm sure the SciPop web page would have links to some
We
of your
actually don't
activities.
have, but I could share a copy of this with the SciFest organizers if you're willing to.
Sure, and we'll host it on our
Just
website.
email us. Okay, simpler. Just email us. We've shown you the email ID. Just email us and we'll send it to you.
Perfect. And then Samir, you went into showing us your telescope that you made, right? So I'm hoping just very quickly, if you can take down your presentation and give us a more clearer view.
Oh, sorry.
Are we able to?
Yes. Sorry, I forgot. I was still sharing my screen. Thanks. Yes. There's one in the background here. This is a reflector telescope. So it's actually a 2-inch mirror which is curved, very similar to the SALT, which is 11 meters in diameter. This one is only 2 inches. And it's usually not made of this clear pipe. It's made out of an opaque one. But you can see it's made out of, the stand is made out of plywood. And this part is the holder, which is just 2 clamps, which is very easy to find in plumbing shops. And similarly here, this is the 2-inch telescope, 2-inch because its lens is 2 inches in diameter. It's an achromatic, good quality lens. So that is the only costly part of this telescope. This costs more than the rest of the telescope. So this in India, it's sorry, I don't have the currency conversion, but it costs around 800 rupees at the max. And here, rest of the things, all these things, you know, nuts, bolts, everything you can get in a plumbing shop. I'm getting it as close as possible to show you. Yeah, you see, and how easily it moves. See? I can move it around. If I place it like this, I can move it up and down, which is the altitude axis, and I can move it around left and right. So that's all it needs to point to any direction quickly. So it's an alt-azimuth axis, all made out of pipes, and it stays on pretty well. You see, I left my hand and it stays in that direction. So that's very important for public observation. So if you're doing this at school or any kind of open public event, it needs to be sturdy, so it is there. You could always, again, do something called, you know, jugaad in India. You could just put a piece of newspaper inside the threads and it becomes tighter. So just you know, figure it out. And as I said, the lower part is one of the favorites of Indians. So we make flatbreads, rotis on this kind of a rolling board with a pin. So here we've just you know, attached this clamp here, and the clamp can also come off. So if I do this, all this can be removed. So you can just take this off. The stand comes off separate, and you can pack it in a bag and take it out. So lightweight and easy to use telescope.
That was actually fantastic. Thank you so much for showing us exactly how you made this. And I mean, every part of that is, as you can see, very easily accessible in a plumbing shop. And it wouldn't cost a lot to actually source those parts and make it even an activity in the classroom to start putting it together. I have a question from Camille.
In fact, just a moment. So every school could in fact take up this as a project and make at least one of them in front of the kids. In fact, in our rural schools, for our rural outreach, some students have made them, some teachers have made them with students. And the best part is, most of the parts are replaceable. If the kids learn how to respect the optics, the glass parts, the rest of the parts are replaceable. So if they can be lent out to students for a night, they take it home, do observations, bring it back. So it can be like in a library. And if they break any part, they can just go and replace it from their plumbing shop. So it's so easy, and there's very little reason to be afraid of a telescope that we might break it or something.
Thanks, Samir. And I think if you're in a classroom and you work with kids, it's very important to have things that are easily accessible, cost effective, because at some point you're going to have to replace some part of it. The other question from Camille, how would one go about creating a sort of 3D printed stencil of the star positions? Is an accurate star map available for downloads as a CAD sketch maybe?
I can send you the maps that I have. If again, as I said, if you please email me, we can explore this further and send you something more.
And then the last part of that question, then a stencil can be printed with holes in certain positions for kids to easily find a constellation. Yes.
Yes. So I mean, you need not always have very accurate positions of stars for your stencil, because at a small level, they are not, I mean, if we've done this before, so we've just taken a cardboard piece and assembled it like a football. Like, you take pentagons and hexagons and join them together. All of these have a stencil, dotted stencil, and you put a light inside them, turn off the lights in a room, and you have a planetarium there, right, or on the roof right away. So these need not be so accurate, and you can just do it with maybe a tin can or something like that. And people have done this for a long time. And there are mobile planetariums also available, which have these custom made. So there are companies which are selling these. So they have these accurate stencils available as well. But as I said, then you need not always go for accuracy. If children first enjoy this, then they can always go to a planetarium later for a much better experience.
What have you guys found to be more effective educational tools for kids? Visualization via software or practical demonstration where kids get to physically look through telescopes or physically interact with astronomical concepts?
I think the latter is much more effective, and that's because we always relate to experiences. So these experiences are in a virtual environment. It's slightly impersonal. Here, I'm sharing a story. I'm sharing my experience. I'm sharing something that I can do with the confidence, and they kind of aspire to get that confidence. So that is something which goes lacking in a thing. A teacher is always a role model, also a hero or a heroine for the student. This is something we always remember, and then we try to give an inspiring example, not just content of a syllabus or something, but also become an inspiration for having confidence in doing something or solving problems, etc. So it's always better that we sometimes also show them the problems we come across while, let's say, setting up a telescope, and then ask them a solution for it. That remains in their mind a longer time than a virtual environment.
I definitely agreed. How would you approach cultivating a child's interest in the subject without scaring them off by the complexity of the subject?
Right. So again, as I always do, I involve their own experience with the subject. For example, maths might scare some people, and if they do not see the application of it ever. But if you can show good applications of it, like I just said, you could find the distance to the moon by doing some simple maths using the geometry that you learned in class. I think that will be staying in their mind for a longer time, and they might in fact consider not getting scared of the subject for a while. Children are very flexible, so it's at that time they don't have inbuilt strong beliefs so much. So they can still change things, and I've seen many students actually start liking physics after they came to our workshops and saw things in action.
Thank you. And I think when it comes to the complexity of the subject, depending on your audience level. So you would know what kind of audience you're speaking to, and definitely then you target that specific audience group.
Of course.
And yeah, so and then the last one, just before we sign off, if possible, could you please share schematics of your low-cost telescope?
I'm sorry, what do you mean?
Schematics. So basically, you know, yeah, the design of
Sure.
the telescope.
Sure. Again, it's if you email me, I'll send you the link to the place where the design is available.
Okay, and with that, I would like to say thank you very, very much to Ayuka Sai Pop for joining us today. We've had a fantastic time. We've had interactions on Facebook, and what we notice is mainly after our sessions, people start logging in and watching throughout the day, which is really a fantastic way. And I'm sure many people are going to be inspired by using ourselves to teach astronomy as a concept in classrooms. You know, during lockdown, I think parents were faced with the reality that they have a lot more hours to spend with their kids during the day, which they generally don't do because their kids are at school. And these are very, very effective means to assist them when trying to, you know, become teachers, explain to their kids different concepts. Thank you very, very much for this, Samir and Sanal. And on our side at the observatory and at SciFest as well, we look forward to many, many more interactions with you, definitely more videos with you that we'll make available in the future. Because as we know, the time is very limited for these, and we'd like to have a lot of time to explain all of the different concepts that we can, you know, to a public audience and engagement. So from my side, from the South African Astronomical Observatory and from SciFest Africa, thank you very much. And that's us signing out.
Thank you, and bye. I can see Derek there just for a moment. Hi, good to see you.
Thanks very much, Samir. That was great.
Thank you very much. Thanks.
Thank you. Bye-bye.
Bye.
Cheers.